Hi guys, welcome to our channel of Sciences and Mathematics. Thank you for subscribing to our channel. I'd like to encourage some of our members also who have not subscribed. Kindly go to YouTube and search Sciences and Mathematics or at best Heritage 6110 and subscribe and follow our content so that we can be able to maybe engage with one another and discuss and assist each other more. So for today, our discussion is going to be the stoichiometry of chemical equations. And this is going to assist us, of course, in trying to represent how different chemical reactions occur and how the different volumes that are taking place in the reaction and the product side can be represented. This, of course, comes from the concept that, as we know, chemistry especially deals with the reaction or maybe interaction of matter at the micro level, as contrary to the physical aspect which deals with the macro level. So in this case, we're going to see that the reacting parts can be able to be represented in terms of quantities, which basically are reacting volumes. So stoichiometry of chemical equations try to represent the quantities which are reacting versus the quantities which are being produced. And this in an aspect follows the laws of conservation of mass and the energy that we have already looked at the concept of enthalpy. So in this case, we're going to write chemical equations in forms of words and symbols and try to see how we can be able to represent them in terms of a stoichiometric form. So thank you. Welcome. So for today, we're going to look at the stoichiometry of chemical equations. And this basically is going to deal with the concept of balancing chemical equations. Balancing in this sense comes from the fact that whenever chemical reactions are taking place, we have to account for the mass and the energy that is involved, and also try to represent this particular species which are reacting and the products which are formed in forms of their physical state and the number of moles that are taking place on the reactant and the product side. So basically, we say that we can represent a chemical reaction generally by having maybe element A reacting with B to form product C and D, or maybe we can have just a simple equation where element A is reacting to form B. So this one implies that element A can react to form a final product, maybe which is undergoing a particular change due to temperature or something like that. But basically in this case, we are going to stress on equations which form this specific format, whereby this one represents the reactants and this other side represent the product. So subset, we are going to account for the specific quantities for the reactants which are taking place and the products which are formed by trying to represent them in specific ratios that I've talked about. Now we can make an improvement of this specific equation by trying to illustrate using coefficients the reacting volumes. So this is a general equation for the reacting volumes using coefficients of these letters for the reactants and the product respectively. So A is reacting in volumes of this quantity with B in volumes of this quantity to form C and D. Now, for us to obey the laws of conservation of mass, we're going to see that we have to balance or maybe cater for all the volumes of the reactants that are taking place on this side and the products which are formed. So basically that one entails the stoichiometry of chemical equations. And as I've said, this means balancing of chemical equations insofar as those aspects of volumes and others are concerned. So a normal balanced equation in chemistry is referred to as a stoichiometric equation. So we refer to as a normal balanced equation in chemistry as a stoichiometric equation. And therefore that equation is the one that we refer to as a balanced one. This one helps us to predict the mass of the reactants and the products which are taking place in the reaction, as I've said. And of course, this balanced chemical equation is going to show some specific aspects. The first one, from a balanced chemical equation or a stoichiometric equation, we are able to know the reactants and the products. The reactants and the products. And secondly, from this balanced equation, we can be able to know the symbol and the formula of substances that are taking place in that chemical reaction. So basically these are the symbol and the formula of the reactants and the products. So from this equation we can be able to state which reactants are taking place and how, or maybe represent the reactants and the products. And from the quantities that I've talked about, then we can be able to know the number of moles taking place in the, or participating in the reaction. And lastly, from a stoichiometric equation, we can be able to state all the reactants, all the states of the reactants and the products mentioned in this case. So we can be able to identify the state of the reactants and the products. Use it, and in that sense, of course, we can be able to state them which reactants, which products are being used. So the stoichiometry of chemical equation is very important in the sense that whenever we are trying to represent a general chemical equation, either in maybe a stoichiometric form or the forms that are using these specific laws, any violation of these laws is going to violate that nature of an equation, and therefore it cannot be regarded as a chemical reaction, and it's not going to be accepted by the community of maybe analysts or scientists who are dealing with this specific aspect of maybe chemical analysis, etc. So most of our discussions that we're going to do are going to entail the compliance with the 4 specific rules that I've stated. And in any case, maybe if it's not represented, then that's a violation of this specific rule that I've said about stoichiometry of chemical equations. So much of our discussion for this topic is going to entail the use of examples in trying to illustrate how we can be able to write these stoichiometric chemical equations. Now we have 2 sets of equations apart from this. Now basically 3, but we're going to start with a relationship between the 2. We have what we call the word equations. Word equations, and then we have chemical equations, which of course comply with those rules that so basically this we're going to just navigate around these 3 aspects of stoichiometric of chemical equations. We're going to have a word equation of the chemicals which they are reacting, and then we represent it in form of a chemical equation and try to see whether we can be able to manipulate it to comply with the stoichiometric equation. Now suppose we have a chemical equation of the reaction that occur when magnesium ribbon is bound in oxygen. This can be represented as magnesium is a metal, so magnesium plus oxygen reacts to form magnesium oxide. So we said for a stoichiometric equation it is represented using the symbols. So we are going to have the symbol for magnesium as Mg plus oxygen. Now this is going to form a product that is magnesium oxide. Now in this case we are going to see that the reacting volumes and the product that is formed are stoichiometrically balanced. So therefore this one we're going to have oxygen 2, so we're going to balance this by indicating those specific coefficients, that is for 2 for the one of the reacting species and 2 for the product, to balance the equation. Now again we have to state the physical state of this particular reacting species and the product. So for magnesium it's going to be a solid, it's a metal reacting with a gas diatomic oxygen to form magnesium oxide, which is a solid. So this specific equation is a chemical equation which has been balanced, and therefore we refer to it as a stoichiometric equation since it's referring to the symbols for the elements which are reacting, and then it is being also represented by the particular states of those reacting species and the product, and therefore the balancing mole ratios has been obtained. Now we can also have different types of reactions. For instance, during electrolysis, we can have water which is being electrolyzed. Now this is going to be water being electrolyzed to produce oxygen and hydrogen gas. So this also we're going to do a balance in this case and have that specific equation represented as that. So this is a liquid which is producing two gases at the anode and the cathode. So we can represent that one using the the chemical equation that we have seen on the board, and now it can be written as a stoichiometric equation. So the process that is taking place in this case, of course, is electrolysis, and there are some other conditions that we're going to see which are going to accompany some chemical reactions of that specific nature. So we have a different range of chemical equations depending on the nature of the reactants and the product, which can be represented in form of stoichiometry of chemical equations. Now this of course accompanies different reactions that we know. It can be combustion of a substance, like especially the hydrocarbons that we talk about. It can be a neutralization reaction, which is an acid-base reaction, and maybe it can be an electrolysis reaction like the one that we have mentioned in the board. It can be even a dissociation, etc. So different kinds of chemical reactions that we come across can be able to be represented as a stoichiometric of chemical equation. So far as this topic is concerned, so long as we ensure that the reacting mole ratios have been represented where the symbols of the reacting and the product species which are taking place have been well represented as required, and the states of those reacting species and the products is well represented. So in any case, maybe if we are told that we try to balance an equation of the reaction between barium carbonate and hydrochloric acid. Now if we are required to write a reaction between barium carbonate and hydrochloric acid, so we're going to have a symbol for barium carbonate represented. I hope my symbols are okay. So barium carbonate is represented as that, and it's reacting with HCl. Now this is an acid carbonate reaction. It's going to result in the production of a chloride, that's barium chloride, plus a CO2 gas, and then we are going to have water. So therefore we're going to see that the product, the reacting species and the product have got their moles or the reacting ratios represented correctly for them to balance. This is a solid, and this is aqueous, and this is aqueous, this is a liquid and a gas. So for us to do this balancing, the barium species on the reactant side is 1, 1, and then the carbon is 1, 1, oxygen is 3, there it's 3, hydrogen it's 2, there on the product side it's 1 here, so we add 2. That one makes the chlorine on the reacting side 2, the chlorine on the product side 2. So by adding 2 on this side of the reacting species, then we form a stoichiometric equation that is represented as such. So basically that's the format that we're going to do or use in order to try and balance other chemical equations that I've listed on the board on this side, depending on whether it's an acid-base reaction, it's an addition reaction, neutralization, etc. So basically that's how we represent the stoichiometric chemical equations. Of course, we're going to mention one here and there as much as it's required in any of our videos that may require the concept of stoichiometry. So that is it for today, guys. Bye. God bless.